Hello there! Okay, 2 or 3 videos ago I did a overview of my hands-free, remote controlled astrophotography setup. Involved using the Celestron with its provided app that you can get on Android or iPhone, and using the Sony camera mounted on these mountings with the remote app for the Sony camera also. Now, it wasn't an introduction for a guide or anything like that. It was just, this is what you can do if you haven't got a telescope. This is your options, because there's been a lot of videos out there that show you that. Now, it was partially automated because this knob here is a manual control for focus. And now if the thing's out on the patio for me and it's freezing cold in the winter and I want to be inside, sat by the computer at warm, doing other things, looking at stars, looking where to go, doing research, and moving it and changing the focus, you can't. Even though you can set the focus because it's kind of infinity for a lot of things, sometimes you do need to tweak it. Now, I was wondering, as a project, how could I automate that too? So this is what this video is going to be about. It's the start of the road to fully automating the telescope, including the manual focus knob, remotely, not just having a push button that I can run out and press it. Now, I found this super cheap stepper motor, because I'm off work at the moment, so I spend a lot of money on any random projects that might not go anywhere. And I thought this project's going to be, it may not be that practical, but it's going to be a lot of learning because it involves electronics, a little bit of programming, and then maybe some machining for a bracket. So the plan is that a motor like this may not be the one, but it'll be something like this. This is very good for prototyping because it was only $5 with a little driver as well. And imagine we can sit this in a bracket inside here with a pulley on, and we can either remove the knob or have something that fits over the knob, so we can still use the knob manually. And then that'll be a complete unit. But that's a stepper motor that can drive a knob, but what do you drive it by? And I want to drive it remotely. So I thought, how about using an Arduino with some software, because I really don't have the knowledge to devise some circuitry, some electronic circuitry. So I thought using an Arduino with some software and then with a Bluetooth add-on. All sounded very complicated, but I ordered the components. They were pretty cheap. I think it was like 25 bucks. We include the motor, the Arduino and the Bluetooth add-on. And then I found a free app, and then I got reading about the software. I got a book on Arduinos. And I got quite well into it. I'm going to move over to my desk and we'll have a look down at what I've got and we'll put it together and I'll show you how easy it is and where I went with that. Okay guys, these are the stepper motors we were talking about. Now so this is going to interface with its own little driver that comes with it. So this whole thing was I think $6 or $7. So that's like £4 or something. It's ridiculous. And it's not as simple as I thought it'd be. I thought it'd just be like a drive, and then when you program it, it'd be drive left, drive right, and then you could set a speed and how far you wanted it to go. But they've actually got 4 wires going in there, and it's well, it's actually 5 wires, I guess. Yeah, it's 5 wires, and it's quite complicated how it uses it, and there's several different modes the way it can be used. There's a stepper. There's a lot of videos on these. If you search for the 28BYJ-48 on YouTube, you'll find a lot of very involved videos, probably more comprehensive than you would like. So yeah, so we can plug this into the driver and it will then plug into the Arduino, which I've got here. So I'll plug this in and show you how simple it is to get it working with already existing software out there, what people have made for different things. So this is the Arduino. I've got the Nano. The only time I've used an Arduino before was for my 3D printer, and a lot of that was just kind of off-the-shelf programming and stuff, what people had done. And programs are already out there, so it's quite easy. You just program it yourself, but it's not difficult at all. So, and that was 2010, I think, when I built, maybe 2009 when I built my 3D printer, my first one. So it's been a while as well, so they've come on a long way. So I think mine's like a mega and it's this big. For the 3D printer, and I'm actually working on something else next week where I'm going to get back into Arduino for a CNC machine. I'm building a large CNC machine, which this little project will also use, hopefully. So this is definitely going to be a long-term project that involves machining, programming on Arduino, programming on Android, and then a little bit of electronics. So yeah, so the Arduino, you can just have a breadboard, really good for development. If you just want to play with things really quickly, a breadboard's fantastic. You can plug everything in there. They basically run in parallel, so these are all the same circuits. So here you've got 30 rows that are all joined together on each side. So you can plug this down the middle, and if you do it this way, the pins will actually match up with the numbers you're using. There you go. And this will run off a 5-volt battery, which I have, just one of these. You can plug it into a USB, it'll work fine off that. I've got a power bank, a mini power bank, so I can plug it into my phone's going crazy for some reason. So I'll try and plug this in so we kind of understand what's going on here. So we've got the Arduino, and then also I've got a Bluetooth module I bought. So this connects to the Arduino, and then it should allow you to connect to the Bluetooth module, and then you can send commands from whatever you connect it with, whether it be a PC or a phone. You can send commands to the Arduino, and that's the plan, is how we'll work remotely. So we can plug this in here so we can see the contacts. So those 6 rows are now Arduino, and what we can do here is, I may as well do this or run the video to show you how easy it is. So this Nano uses an old US 2 or normal size USB, whatever they were called, can't remember. We'll plug that into the power bank, so that means we got power on there. Okay, and then we can use these little pins and wire this up. So on here, I can go back and do some video of this, but I mean it's pretty basic. The pin out, you just want to search for Arduino pin out, whichever version you got, whether it's the Nano, the Mega, I don't know the names of them. So we basically want to put some power into these rails so we can use them for the Bluetooth. So on here we have a ground and a 5-volt, which you can actually power the Arduino by as well. If you plug that into a circuit board and you want to power it from that direction, you can, rather than the USB plug. So that's ground, so we'll plug the ground into here, and then the 5-volt pin is that guy. So now that rail works, and we can test it by plugging in. Got quite a lot of these little things, luckily. So we can go and plug the ground in on the Bluetooth. Sure I get that right. My eyes are getting old. See those little numbers, and then the VCC on the Bluetooth. So that should light up now, and it'll blink really fast when it's just kind of searching. It's kind of in pairing mode. And if you look for that on your phone, I'll actually go through that on the phone. You'll be able to log into that. But that's not actually connected to anything yet. So it's got power, but it's still isolated. So if we have another couple more of these guys, which we don't. Well, I've got one of them. And so what you do here is you plug in from, you've basically got transmit and receive on both devices. So the Bluetooth wants to transmit, so you want TXD to the receive port of the so to the RxD port of the pin on the Arduino. The RxD pin. Okay, and now I need another jumper. So I'll skip ahead. Okay, so we've got another jumper now. I'm back. So we've got the receive port on the Bluetooth of this guy, and we want to go to the transmit port of the Arduino, which is this guy. So that's it basically. Now your Bluetooth is powered and it's connected to your Arduino. Now on the Arduino we have some code already, and what I'll do, I'll plug in the motor. So I've wired on the back side of the motor for these are the data pins on the driver. I've wired these up, and I can plug these straight in too. Now on the Arduino you have many in and out pins for data, and you have analog pins and you have digital pins. So you can choose so many of those pins, and then in the software you assign which pins you want to send commands to. So the software, I was actually writing it myself, and I'm not very good and I'm pretty new at it, and I found this guy, Crazy Logic is his YouTube ID, and he's gone into it in depth, and he sounds like he's a really good programmer because he's done a really comprehensive program for these actual motors as well. So I really got lucky finding that, and I downloaded it, and he's actually done it a lot more comprehensive than I think what I need. So he's doing it for multiple motors, and I just want it for one motor. So I was able to go in and delete some of his code out even and make it a bit simpler. And then I need to add some later because I need more levels of adjustment, but not that many. So I'll go through that, and I'll basically join this guy up. So yeah, we're on pin 8 to 11 with this. So that's 9, and I kind of ran out of jumpers here, so I just used a bit of copper cable. Seems to work. So there we go, 8, 9, 10, 11. And then this guy can have power. I'm not sure what I was doing here. I'll just plug those through there so they don't touch. Touch something. This is a bit dodgy, but this is how breadboards get. So on here we've got, this can be for 5 to 12 volts, but I think if you move the pin over it goes to 12. So now we've got on 5, so we've got plus is the furthest away from me. I don't have a proper size jumper for this 3, so we'll use this guy. Prototyping. So we'll plug this into the plus rail, and this guy, that's definitely a minus, put into the ground. There we go. So that should be powered up now. Who knows? So basically what this is now is we've got the Arduino with some code on it, and the basics of that code is if you send some letters to the input into the serial of the Arduino, it will output to the motor through those pins a certain amount of steps. And the chap from Crazy Logic, he had it set by default, so he had, if you send L to turn the motor left, it would be 2000 steps, and R would be 2000 steps. Now this motor is 4000 steps for 360 degrees, so roughly that's, if you divide 360 by 4000, it's 11, I think, is it? So it's 4000 steps. So yeah, so you divide it by 11, and that would give you 0.09 degrees per step, I think. Let me just check that. So when I put L in, it moves 2000. So 0.09 times 2000 should be 180. Yeah, okay, so that's good. So each step is 0.09 of a degree. So with the program, if we change, this is all inside the Arduino. So in the program, if we change to how much we want to move it, so if we want to move it 30 degrees, say, we just work out how many 0.09s do we need to go to get to 30 degrees, and how many steps was that. We change this, so L would equal 30 degrees by, how many steps it would be. And also, if we add more lines to this, and more so say if we have our phone, and then we have some software in here, and this is where I want to get to really. So we'll just have, say, 3 adjusters. So we'll have like small, medium, and large. And we'll say what we've already got, 2000, is half of turn. Now you have to think, when this links over to the knob, depending on the size of the cogs we use, will depend on how much it turns. And also with the manual knob, I think you have to turn it a lot to go anywhere with the focus. So until I got it all installed and play with it, I'm not really going to know how many steps is a small amount of steps. But let's say 2000 is medium. So we can have this one as what it's already at. So we can have this as L and R, and it'll move it 2000. And this would be, right would be clockwise, and this would be counterclockwise. Okay. And then I want to put more lines in here. So say I put like P and N, and P's 4000, and N's 4000. P would be clockwise and N. So I could put over here P and N, and that would be counterclockwise, and that would be clockwise for N for 4000. And then we could have, say, J and Q for small, and it could be say 500. I think something just fell off my shelf. The poltergeist. And over here we'd put J and Q. And connect. So yeah, so this is basically the whole system we've got here. So we've got the Android app that I know nothing about yet, but there is an Android app already out there where we can try and get this working with, and then if that works, we have the whole system. I don't know what's going on there. The ghosts, go away! Maybe I need a cup of tea. Yeah, so we import, we want a small movement of 500 counter clockwise. So we press this button here in the app, and through Bluetooth it sends it to the Bluetooth module, and it sends a cue to the software that the chaps wrote, not me. And then the software says, okay, move the motor 500, which would be at the moment would be, if that's 180, it'd be 45 degrees at the moment, I think. So it'd move the motor clockwise 45 degrees, and then it would move the knob 45 degrees. So that's pretty much everything we want. What we're missing, all we're missing is the bracket, which is completely undefined yet, and the cogs and the mechanics, if you will. A few changes to the software, which is super simple, I think, because that chap's already done all the work, it looks like. And then the Android is probably the biggest work because I know nothing about it, but it's projects like this, even though the end result might not be that useful, having the project helps you learn really well because it's very tangible, and I've always thought that. So yeah, I'll show you. I will see if this will connect. I don't know if the camera's picking this up, but wherever the app is, and I'll link to this app. It's really cool. Yeah, okay, it's called AudioJoy, this app. So let me just check that out. You can't see it at all. Let me turn the light down now, and then we'll be able to probably see it better. And that light is my new high CRI light. I need to do a video on that. It's pretty awesome. It's using a LED from China, but quite an expensive one. Oh crap, didn't mean to do that. There we go. Oh, you still can't see it. Okay, that's better. Okay, so basically this app, it's very basic import, so it should be able to import anything in a configuration manner that would work with the Arduino input. So if we connect this, so here we can see HCL5, that's the actual Bluetooth module and the MAC address for that. And it says it's connected, okay. And then get data is like reading from the Arduino. So you could have the Arduino hooked up to sensors like a temperature sensor or strain test or anything, and you could just have it feeding information over the Bluetooth to this. Now what we'll try here is we'll try and send an R, and I've not used this for a day or so, so I really don't know if problems have started, but yeah, so we'll put R and send data. Okay, so nothing happened with the motor, but it came back 2000. So the Arduino thinks that it moved it 2000 because it reports back with where its position is. So if we did an R again, it should say, it'll move it 2000, it'll come back 4000. Yeah, there you go. And if we send L, it should come back 2000 because it moves back, because it's gone counterclockwise 2000 and 2000. And I don't like it worked. Okay, so I wonder why this didn't move. I don't think the power connector's good enough. It's not staying on. Oh, there you go. Just need pushing down further. Okay. So we'll send R, and it's vibrating, it just didn't move. I wonder if my pins are in the wrong way. And we'll send L. And nothing at all. So let me just check these pins. And hopefully that works a little bit better. So we'll send an R. So it's vibrating, but there's something wrong with the motor now, I think. I guess that's what you get for a $2 motor. We'll send an L. And nothing for some reason. But the software thinks it's doing it, so it's something wrong with the driver motor. But you can see what we've got here. I mean, it's just a proof of concept, really, to get all the things together we need and just say what we need and what we need to work on. So the Android app, somebody's already got a really good one working, so it's obviously you can do that. How much work it is, I don't know, but I'll enjoy learning how to do that. The Bluetooth works so easily. For the price, it's been great, and the size of it's amazing. I love it. The Arduino seems to work great. Updating the code and everything's okay. Now this stuff, I maybe just need to wire it in a bit better. My wires are really bad and dodgy. I just kind of rushed it just to see if it would work and see how easy it was. But that's the basics of it. So I know I've gone into that really deep, but the actual bracket is in different can of worms. Basically, I'm gonna. I've been wanting to build a CNC for a long time because I'm actually a structural engineer. That's my job for aircraft. So in my work, I design a lot of components. You know, I design. That's all I've ever done for 20 years is design components. So I've always wanted to get a CNC machine where I can make my own billet machinings and molds for, you know, carbon fiber parts, because I've done carbon fiber design for a long time. And the other night I just ordered all this stuff. It's like come to a time where the quality of the extrusions and the kind of things I wanted. So I hope to, on CATIA, which is the CAD Atelier, I hope to design it all out, but it was spontaneous. So next week you're going to see videos appearing called something like Spontaneous CNC Build Part 1, and it'll probably go up to like Part 400. So, and then if I get that working, we'll design up, I'll do some videos of like on CAD, design the part up, because this is like a really easy thing for us to do. Design that up, and we can go through the process of sending that to the machine. It'd be really interesting to knock that up. And I've got 100 things that I'd love to machine, so should be a lot of videos, and be really interested. And I'm sure the machine, because I'm not working at the moment, I'm kind of on a budget, I've ordered a lot of bits that I was, you know, if I was working, I would have I would have just got the best bit. But now I've really gone and like, I kind of justified the parts, like some of the stepper drivers and stuff. I've looked at the specs, and it's like, okay, it says it does like 3.5 amps, and the motors are 2.5 amps. So I'm going to go with the cheap ones, you know, rather than go for things that cost 10 times as much. And also, I really fancied servo motors, and I'm going for the stepper motors. Anyway, whole new can of worms. It's going to be great. So this is the project for fully automated astrophotography, and yeah, it should be fun. If you know this can be done a lot easier, please comment. If you want more info or anything, just comment and we'll reply back or do some more videos. Thanks very much. Bye bye.